Hey guys, welcome to another Flutter tutorial. My name is Tensor. Today we're going to be looking at Cloud Firestore and how we can interface Cloud Firestore with a Flutter application. Specifically, we're going to implement a full CRUD system. This means create, read, update, and delete into our application. So many of you guys are probably wondering what the difference between Firebase and Firestore actually is. Firebase is a real-time database that is structured with a JSON tree, whereas Cloud Firestore is stored with data in what are called documents, which are essentially just key value pairs, and collections, which are collections of these documents. The storage with Firestore is very similar to JSON and very similar to Firebase, but there are a number of advantages to using Firestore as opposed to Firebase. Firestore has better scalability. It also offers better querying. It makes it easier for us to write data to the actual store. And of course, it has its own pricing model. To get started with Firestore, we want to go to the Firebase console, and then we want to create a new project. I'm just going to call our project Flutter Firestore, but you can call it whatever you want. And I'll just hit Create Project. This will go ahead and generate the project. And all of this is exactly the same as what we already did with Firebase. Once it's complete, you'll have the same console as you had with Firebase. But now we want to go to this database tab, and we want to specify that we want to use Cloud Firestore Beta. And I'm going to make ours in test mode, which means anybody can get a database reference and read and write from the database. So I'll just hit enable, and this will set up our Cloud Firestore for this project. So here we are in the database view, and all I'm going to do is create a new collection. I'm just going to call this Flutter_data. And we just need to remember that collection name so that we can reference it inside of our application. For the document ID, I'm just going to generate a auto ID, and I'm just going to click Save, and this will create our collection with non-specific data inside of it. So we don't really want to worry about the shape of the data currently. We'll worry about it inside of our Flutter application. So you can see here we have a collection, and then we have a single document that has nothing inside of it. Alright, so let's go back to the project overview page, and let's set up both a iOS and an Android app. So for the Android package name, you can get this from inside of your code. Mine is named com.example.firestore example. I just want to click register app, and now I want to download the google-services.json file like we did with Firebase. Once we've downloaded the file, we want to put it inside of our Android application, part of our Flutter application, right inside of the Android app folder, so right next to the build.gradle file here. Now we need to actually set up the plugin, so we go inside of build.gradle. This is the project level build.gradle, and we want to add class path com.google.gms :google-services 3.2.0, and then in the app level build.gradle, we want to come down to the very bottom and add this line here, which applies the plugin to the application. So apply plugin com.google.gms.google-services. And that's all you really need to do to set this up for Android. Now let's set this up for iOS. Inside of the project overview, you just click Add Another App, and then you click Add an iOS app. The iOS bundle ID will be the same as your Android ID, so you just get that same string, which in my case is com.example.firestore example. And now we can download the Google service-info.pls file, and we're putting this file inside of iOS and the runner folder. Unfortunately, the next steps I can't really do. These are adding the dependencies to your application. The reason I can't do it is because I don't have Cocoa Pods on Windows. However, if you do have a Mac device or a Linux device, then go ahead and run these commands, and you should be ready to go. Alright, so now with Android and iOS all set up, let's bring in the Dart dependency. So in our pubspec YAML, we want to bring in cloud_firestore, and the current version is 0.7.0, so that's the version that I will be using. Once it has been installed, you can just import it into your application, and you actually do not need to add any more configuration to make this work. So unlike before where we had the Firebase core and we set up a Firebase app using that, we don't have to do that with Firestore. Instead, we can directly reference the instance inside of our application when we want to read or write data. Before we start coding, let's just go over the boilerplate. We've got two stateless widgets. One of them builds out our material app, and then the other one builds out an empty scaffold. The one minor change that I've made to this code is that I've added this debug show checked mode banner, and I've set it to false so that we don't have the debug flag in the top right corner of our application. I'm also using the themedata.dark theme. Now inside of the scaffold, we want to set up our app bar. I'm just putting in a title of Cloud Firestore example, and then I'm also going to add center title and make it true so that our title sits in the center of the app bar. Now there is a main reason why we're doing this, and we'll get to that later. The main way that we're going to interface with the Firestore application is by getting a stream. And the way that we get this stream is by using a stream builder, and the stream itself is our firestore.instance, which gets an instance of the actual Firestore, and then we want to reference the collection that we made, which was called Flutter_data, and then to get this stream, we call the .snapshots method on this, and this will give us a stream of query snapshot. Then inside of our builder, we can bring in our build context, and we want to reference the asynchronous snapshot of query snapshot, and we'll call this snapshots. So this is where all of our data will be. Inside of our builder, we're going to do a quick if check. Then we want to return a circular progress indicator. Otherwise, we're going to return a custom widget that we're going to create called Firestore list view. And this widget will take in a variable called documents, which will be the documents that we're bringing in from our snapshot. So to get to this, we just go snapshot.data.documents, and this gives us the documents inside of our collection. Let's quickly create our Firestore list view. We'll have it extend a stateless widget, and we're passing in our documents. Like I said before, our documents is a list of document snapshot type. So each of the documents inside of our Firestore is represented with this document snapshot, and we have a list of them because we're going to have multiple different documents. So we just pass that through the constructor, and then we want to create a build function, which we can then use to build out the user interface, which will interface with our data. The body for this widget will be a list view builder, and our list view builder will take in the item count, which will be our documents.length, so the length of our list. Then we'll specify an item extent. This is something that you don't have to do, but I'm doing it because I want to specify the area that each of our items is going to take up on the screen. And I'm just going to specify this as 90.0 to give them a wide breadth. And then for our item builder, we're going to take in the build context as well as the index, so the current index that we're iterating through. And of course, this index is based off of our documents.length. We want to specify a local variable inside of our item builder callback function called title. The title, which is a string, will be equal to our documents index, so the current index of our documents list. We grab the data, and we're going to specify that we want the title key, which is a key that we haven't created yet, but will be generated by the application. So this is just a reference to a portion of the document, and then we're going to convert the information that we're going to put in there into a string. Below this, we can return a list tile, so each of our elements will be inside of a list tile. The title for our list tile will be a container, and then we'll decorate the box a bit. We'll make it so that it has rounded corners by using border radius.circular and passing in 5.0 pixels, and then the border itself will have a color of black. We want our items to also have a nice little bit of padding between one another, so we'll specify the padding and we'll give it edge insets all of 5.0. And then inside of this container, we want to create a row, and this row will basically contain all of the data that we're going to create for our application. For now, what we can do is inside of our row, we can create an expanded, and then we'll have a text widget which will have our title inside of it. And actually, I forgot that we had a black theme, so the border should be colors white. So anyway, we've got this expanded with a text widget inside of it. The text widget is referencing our title, which is the title key of the specific document that we're iterating through. If we go into our Cloud Firestore database, we can add multiple documents if we want. So here I've got two documents. One says testing for the title field, and then the other one says this is a test title for its title field. If we load up our application, you can see that the two title fields now appear inside of these list tiles. So if we were to keep creating title fields, it would then continue to generate more and more list tiles. Now for our application, we want to make it so that we can generate our own data from the application and so that we can edit the data inside of our application. So let's go back up to our scaffold and let's add some actions to our app bar. We're going to create an action which will generate a new document. And it will generate a new document that's actually just clear. So the document will have no string inside of it, and then we can edit the string after we've generated it. In our actions, we'll just create an icon button. We'll give it icons.add, and then the onPressed event will be where we actually create a new document. So here is a way that we could actually add a document to our application. So we can just call firestore.instance.collection, put in the collection that we want, which is our Flutter data collection, and then we can call the add method on it and pass a map to it. In this case, our map is just a key of title and then a value which is empty. Now there is a problem with doing things this way, and the problem comes when you have multiple people trying to manipulate this data store at the same time. So doing it this way will cause what's called a race condition. So if two people are trying to edit the same item, it could potentially cause a bunch of errors and exceptions. So you don't really want to do things this way. So you definitely don't want to just directly call to the collection and have it do things. Instead, you want to call the runTransaction method on your Firestore instance. And then you want to pass an asynchronous callback function to this method. Now what this will do is it will allow us to access the data in an asynchronous way. So if two people are accessing the data at the same time, then one person will get it first and the other one will get it next. So it won't cause a race condition this way. We also want to get our data through a reference. So we have what's called a collection reference, which is just a reference to the entire collection of data. Get a reference by calling firestore.instance.collection, passing in the collection name, which is Flutter_data. And then after we get our collection reference, we can just call await reference.add and then pass in the map like we had before. So now inside of our application, you can see we have this plus sign at the top, and if I click it, we now get an empty list tile appearing inside of our list view. And I can click it as many times as I'd like. So this is all fine and dandy. However, we have no ability to actually edit our data. So to help with editing, we're going to add another key value. This will be called editing, and it will take in a Boolean. So each document will have an editing value, and then we'll also add another piece of data called score, and we're just going to do this to make it so that our application is slightly more interesting. So each of the documents will have a score, and it will have the Boolean, which will tell the application whether or not the user can edit this item. Now that our new documents have more fields than our old documents, we can just delete all of our documents. So we just click this button here and then click delete all documents, and this will permanently delete the entire collection, which is fine because our application will regenerate it for us. So now if I come back into the application, click plus, you can see that a new list tile gets generated, and inside of our database we get a new document that has our 3 fields. And if we wanted to, we could manually edit these as well. Instead, we want to be able to edit them from our application. So to make this possible, what we'll do is inside of our expanded, we'll say child equals a ternary operator that checks documents.data, and it checks the editing key. We want to check to see if it is false. If it's false, then we'll show a text widget with our title in it. Otherwise, we'll show a text form field which will also have the title on it, but it'll allow us to edit the title. So inside of our text form field, we don't need to use a controller. Instead, we can set the initial value to just be our title. Now we want to make an onTap function, which will change our text widget into our text form field when the user taps on it. For our onTapped function, we want to run another transaction on the Firestore to actually manipulate the boolean that we created. So we say firestore.instance.run transaction, and then the callback takes in a transaction type. The callback, of course, needs to be asynchronous, so make sure to mark it as such. We're going to first get a document snapshot by awaiting on transaction.get, and then we're going to pass in the document that we want to reference by passing in documents and then the index of the document dot reference, which will get the reference of the current list tile that we're on. And then after we get the snapshot, we can actually run a update transaction on our document. So we say await transaction.update. We pass in the snapshot.reference, and then we pass in the map of what we want to update. We want to update the editing key value pair, so we reference editing, and then we take our snapshot, and we want to just invert the Boolean value. So if it's false, we'll turn it into true, and if it's true, then we'll turn it into false. We can use the negation operator for this. And of course, we're referencing the editing key, so we pass it into our snapshot, which is a big old map that we're getting from our Firestore. So now if we open up our application, if we just click on the box anywhere, it will then allow us to edit it. So you can see here, it's now a text editing controller. And if we click on it again, it will just become a nondescript text widget. So this is cool and all, however, we do not have the ability to actually write to this text field yet. So let's do that. And the way we can do this is by using the text form field onField submit property. This takes in a callback function, which takes the string of the actual text form field and then allows us to call submit. So whenever the user hits the enter key or whenever they stop typing, then it's technically been submitted. And this will then allow us to submit the actual piece of text to Firestore. This is going to be almost exactly the same as what we did below. So we want to call firestore.instance run transaction. We get our transaction. This is going to be async, of course. And then we want to get a document snapshot. So we await transaction.get documents index.reference. And then we're going to await transaction update. We pass in the snapshot reference, and then we pass in a map where we're associating our item variable, which is the string here, with our title key. So now if we open up our emulator and we open up our Firestore database and we click on this, to make it so that we can edit it, you can see here that editing turned to true. And now we can type in something, say test. And then when we hit the little check button down here, you'll notice that the title has now updated. And in fact, for a little bit of quality of life for this application, let's make it so that the actual text form field switches back to a text widget after the user submits the item. We can do this by calling another transaction inside of our transaction callback. So we await transaction update, we get our snapshot reference, and then we're just going to edit the editing field and just convert it from true back to false. So this is exactly what we did below. So now in here, when I hit the enter button, you can see that the widget changes back to a text widget. So now that we've set all this up, let's expose the score value to our application. To do this, we just create a variable like we did with our title. This time it will be an integer. So we say score equals documents index data score. And now below our expanded widget, we can create a text widget which will take our score and just create a string out of it. So here you can see in our application, we have test, and then we have a little 0 at the end of the actual list tile. Now we want to be able to manipulate our score, so we'll create a column, and the column will have buttons inside of it. We'll have a button to allow us to increment the score, and then we'll have a button which will allow us to decrement the score. So here inside of our column, we can create two icon buttons. One will be an arrow upward and the other one will be an arrow downward. If we open up our application, you can see now that these widgets are actually causing an overflow. And the reason for this is because we've set up our item extent manually. And you can see here, it says it's overflowing by 9 pixels. So to fix this, we just want to extend our item extent. So in this case, I'm going to make the item extent 110 pixels. So now you can see that that overflow error has gone away. Alright, so we have our buttons, but they have no functionality, so let's create that functionality. Both of these are going to be very similar. What we want to do is call firestore.instance, and then we're going to run another transaction. And then inside of the transaction callback, we get the document snapshot like we did before. So again, snapshot equals await transaction.get documents index.reference. And then we're going to await on transaction update snapshot.reference, and then we'll take our snapshot score and add 1 to it. Then for our decrement button, we're going to do exactly the same thing, except we're going to subtract 1 from our score. So now inside of our application, if we click the up button, you can see that it gets incremented, and if we click the down button, it gets decremented. And of course, we can create multiple tiles, each of which will have their own score. So you can see this one has 4, this one has 0 and 0, and we can click the buttons various ways. So now there's one more feature that we want to add to this application. We have the ability to create the data with our plus button. We have the ability to read the data just by displaying it on the screen. And we have the ability to update our data by either hitting our buttons or by clicking our text box and editing the text. Now we need to implement an ability to delete our data. We're going to do this outside of the column that we created. So this is still inside of our row, but outside of the column. And the idea is that we want to put an icon that will sit here on each of the list tiles. It'll just be like a trash can. And then when we click that icon, it will delete the corresponding list tile. So here you can see we can just create an icon button outside of the column. And now it's sitting on the far right of each of our list tiles. So the transaction that we want to run when we push this button will be very similar to the other transactions that we've done before, except this time we want to run the delete method on this transaction. So what we'll do is we'll go Firestore instance, run transaction, and then we'll have our asynchronous callback. We'll get the document snapshot by calling await transaction.get documents index.reference, and then we'll await on our transaction.delete, and we'll pass in the snapshot reference. So now inside of our application, if I click the trash can, you can see that now the tile just disappears. So now we have the ability to delete any of our data from our application. And you can see here, if I open up the database and say delete another tile, it will then delete one of these documents. And let's say I create a bunch, you can see it creates quite a few documents, and I can come through and just delete them randomly, and it will delete them randomly as well. Anyway guys, I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you disliked the tutorial, then by all means, downvote it as much as you like. Have a good night.